Hello, my name is Randall Law, and today I will present an overview of steatite acquisition and production in the Indus Civilization. For me, this has been a 20-plus year project aimed at identifying the geologic sources from which Indus peoples obtained steatite, tracing the pathways through which that raw material was distributed across a vast region, and looking at the ways in which it was utilized to produce the highly distinctive objects we associate with the Indus or Harappan civilization, namely steatite beads, tablets, and stamp seals. Here is a partial list of all of the institutions and organizations that have supported this project over the years. I would use up what remained of my time if I were to properly thank the many, many individuals that generously shared their time and expertise with me. However, I must thank Professors Mark Knoyer and Richard Meadow, co-directors of the Harappa Archaeological Research Project. It was they who first invited me to Harappa to begin this study. Steatite artifacts abound at Harappa. They are found in abundance on every mound, in every excavation trench, and in every chronological phase defined at the site. In fact, if you just consider rock and mineral artifacts, that is, if you exclude ceramics and faunal material, objects composed of steatite are the single most abundant artifact type at Harappa. They make up well over 1/3 of the assemblage. And this pattern is largely true at other Indus sites too. In fact, Massimo Vidale once remarked that steatite, in particular steatite beads, themselves can be considered almost a marker of the Harappan character of an archaeological site in South Asia. The renowned bead scholar Horace Beck characterized the Indus as a steatite civilization. He said steatite objects produced by Harappan craftspeople were remarkable, not only in their number and variety, but also in their extreme beauty and perfection of execution. So let's now talk about exactly what steatite is, where it is found, and what we have discovered about how Harappans acquired and employed this stone that was very clearly of great importance to them. Steatite is a rock composed primarily of the mineral talc, which is a hydrous magnesium silicate. It occurs in two very, very different types of geologic formation. It may occur in ultramafic igneous rock, or it can occur in dolomitic sedimentary rock. And the result can be steatite that is visually almost identical. But given the two very different geologic environments that it may form in, it can have very different trace element characteristics that reflect those respective parent rock formations. Now, the geology of South Asia is such that both ultramafic and dolomitic steatite sources occur at multiple places surrounding the Indus Valley. Harappans could potentially have accessed any of them. So, how do we determine which ones they exploited? Well, the first thing to do is to sample as many of those potential steatite sources as possible. Individual steatite deposits have been sampled to date. Some are dolomitic in origin, those in green, and some are ultramafic, those in black. While this sampling is by no means comprehensive of all potential sources, it is, I would argue, at least representative of the type of stone that occurs in each region surrounding the Indus Valley. Nearly 500 geologic samples collected from the 38 individual deposits in India and Pakistan were compared to 140 steatite debris fragments from the site of Harappa, as well as 60 steatite debris fragments from 9 other Indus Civilization sites. Now, by debris fragments, I mean the production debris left behind from the manufacture of beads and seals. This is unmodified raw steatite, and you can tell that you can see here that it's highly variable. Some of it is jet black, some of it is khaki colored, some is red, some is green. The appearance of this stone in raw form, in raw unheated form, is quite variable. In addition to production debris, we sampled a handful of artifacts where we were able to access unmodified raw material. For example, this broken seal blank from Harappa and the unheated interior of this broken seal from the site of Golodoro. The steatite artifacts and geologic samples were studied using instrumental neutron activation analysis at the University of Wisconsin-Madison's Nuclear Reactor Laboratory. Multivariate elemental data returned by INAA was evaluated using canonical discriminant analysis. Excellent statistical separation between geologic samples of dolomitic origin in green and those of ultramafic origin in black was achieved using this method. When the data points for the raw steatite artifacts are superimposed, it is immediately clear that the large majority of them cluster with geologic samples of dolomitic origin. Only a handful of artifacts fall with ultramafic sources. After further iterations of comparison, which I will not show here due to time constraints, we were able to assign artifacts to discrete sources, or at the very least, to individual regions. So, with this geologic provenience data now in hand, we can provisionally reconstruct steatite acquisition networks during the Indus period. Raw steatite debris fragments and the occasional unfired steatite artifact from Harappa and 9 other Indus sites have been analyzed. These additional sites include both urban centers and lower order settlements in Haryana, Sindh, and Gujarat. The largest artifact set comes from Harappa. Over 95% of it appears to have come from multiple dolomitic steatite deposits occurring across a zone between 300 to 400 kilometers north of the site. With regard to Harappa, this is not completely unexpected, as these are the sources nearest to the site. However, we also see that the large majority of steatite utilized at most other Indus sites, including the urban centers of Rakhigarhi in Haryana, Mohenjodaro in Sindh, and Dholavira in Gujarat, can also be traced to the same dolomitic sources in northern Pakistan and India. In the case of Dholavira, these sources are over 1,200 kilometers away as the crow flies. Now, a limited amount of steatite from sources in other regions does appear to have been utilized at times. Some of this raw material seems to have been confined to regional acquisition networks, such as steatite from the northern Gujarat, southern Rajasthan region, which was used in limited amounts at sites in Gujarat. At other times, stone was transported longer distances. A few examples of steatite from sources in northern Rajasthan are found at Harappa and Mohenjodaro. This study indicates that the primary acquisition and distribution network for raw steatite during this time period ran from sources in the far north southward throughout the Indus realm. So why is this? What makes steatite from certain sources in the far north preferable to raw material from other sources that are often found in much closer regions? Well, the answer has to do with the properties of the raw material itself. Recall the highly varied appearances of the raw steatite production debris fragments from Harappa. Now, compare those to the outward appearances of the vast majority of Indus artifacts composed of steatite. The difference is striking. Most Indus steatite artifacts have a white or off-white appearance. This is because they have been heat treated. Over the years, we have conducted a great many experimental heating studies involving steatite. We have found that subjecting steatite to temperatures between 900 to 1200 degrees Celsius significantly alters the appearance, hardness, and mineralogy of the stone. One of our initial heating experiments involved different colored examples of the thousands of pieces of production debris found at Harappa. As you can see from this before and after image, the initial raw material color doesn't matter. All become white when heated. This is not surprising, as these examples are of the actual material that Indus peoples brought to Harappa. However, we also conducted this experiment on samples of raw steatite from geologic sources found across India and Pakistan. Here are examples from 20 of those sources before heating. These include material from both dolomitic and ultramafic sources. As you can see from this post-heating image, only a handful of samples became white after being heated. Those that did were exclusively from dolomitic sources. So, we did another round of heating that focused just on geologic samples from dolomitic steatite sources. As you can see in the after images, even among these, not all examples became white. But, significantly, those that did were from the very same deposits in northern Pakistan and India that our provenience study indicated were the sources of raw steatite at Indus sites. So we see that white-firing dolomitic steatite came from sources to the north of Harappa. Non-white firing raw material from other regions is also present at many sites, and, since it was there, was likely sometimes used. I suspect that the muddy red color of this famous seal from Mohenjodaro is indicative of the use of just this type of steatite. However, if you wanted your seals and beads to look like this, and ancient Indus peoples quite evidently did for the most part, then you needed to use steatite from specific sources in the north. This pattern of stone from a very specific source or region being distributed to sites throughout the Indus civilization is not exclusive to steatite. The preponderance of steatite from northern sources at Harappan sites is, in many ways, mirrored in the distribution of chert from the Rory Hills of Sind throughout the Indus civilization, or high-quality agate carnelian from Gujarat. In both of those instances, alternate regional sources were sometimes used, but a specific type was clearly preferred. The reasons behind such raw material distribution patterns may be aesthetic, technological, economic, political, or some combination of all of these. But, like the widely accepted patterns for Roy chert and Gujarati agate, the pattern for the steatite distribution outlined here appears to have been very real. Thus far in this presentation, I have focused on the provenience analysis of raw steatite. This has worked very well, but is ultimately limited in that raw production debris is infrequently found in abundance outside of Indus production sites. Beads, on the other hand, are almost innumerable at most Indus sites. The only problem is that they are usually too small for instrumental neutron activation analysis, and the original raw material has been altered by the high heat that they have been subjected to. Nevertheless, in recent years, I have been collaborating with Dr. Brad Chase of Albion College in an attempt to determine the geologic sources of steatite beads. For this new study, we first had to heat treat a set of geologic samples in order to make them directly comparable to fired steatite beads. In addition, the neutron activation analysis parameters had to be adjusted to accommodate the small sample size that is typical of such beads. We have analyzed steatite beads from Indus sites in multiple regions, and, by and large, most appear to mirror the distribution pattern of raw steatite, i.e., they are composed of raw material from the northern Indus region. I will briefly highlight the results of a set of beads from sites in Gujarat. These were provided by our colleagues and collaborators, Dr. Ajit Prasad of MS University, Baroda, and Prabodh Chavalkar of Deccan College, Pune. Although smaller in size, our heated geologic dataset again falls into well-defined dolomitic and ultramafic sample groups. When the steatite beads from Indus sites in Gujarat are compared, we see that they all plot closely with dolomitic sources. And for most of the sites, those sources are located in the northern Indus region, which is typical. However, at one site, Kotatabadli in Kutch, the bead appears to have been made from raw material originating in Rajasthan. It should be noted here that Kotatabadli is not strictly an Indus Civilization site. Rather, it is a contemporaneous site of Sorath or Sorath Harappan affiliation. Four beads from Deccan College's excavations were analyzed. One, like I have indicated, was made from steatite sourced to Rajasthan. Now, this is not typical of Harappan bead makers, clearly. The other three beads were not even steatite at all. X-ray diffraction analysis indicated that they were made from a locally available clay called nontronite. So what we may have going on at Kotatabadli is a situation where Sorath craftspeople are emulating Harappan steatite bead styles. But because they do not have access to the same networks that bring raw steatite from northern dolomitic sources to Gujarat, they have to instead utilize alternate materials from local and/or regionally available raw material sources. Research on the geologic provenience and the technology behind the creation of Indus Civilization steatite artifacts remains ongoing. Many types of instrumentation are employed in this effort, as well as continued experimental studies. One line of research focuses on the production of steatite stamp seals. Studies of whitened seal surfaces are being conducted using X-ray diffraction analysis and scanning electron microscopy. The insights that have been gained are then tested by conducting experimental surface whitening treatments. Another line of research focuses on the characterization and reproduction of steatite microbeads. Experimental studies have indicated that these, the smallest of all Harappan steatite objects, were likely not made using a paste extrusion method as had been previously proposed. Instead, microstudies revealed that they represented the culmination and perfection of a well-documented steatite reduction technology that was developed in South Asia many millennia before the Harappan era. But this will have to be the subject of a longer talk, which I will have to give at another time. I would like to thank the organizers of this colloquium, in particular Dr. V.M. Prabhakar, for inviting me to participate and share this research.